Line is muted. You can unmute yourself by pressing *6 on your phone.
I think it takes a couple of minutes for it to live stream. And then whenever you feel like you need to leave, you can just leave and I'll continue with the other things,
Yeah.
okay?
Yeah, you're in the driving seat anyway.
Okay. Uh-oh. Hang on.
Yeah, you're in the driving seat anyway.
Okay, I think I need to mute something. There, how's that? Okay, let's see. I need to make sure I'm live streaming. We are live streaming over on YouTube, and we're actually a few minutes early, so I didn't think TalkShoe would start until the exact time, but you know, we're live streaming, so we'll go ahead and get started. I have 3 watching over on YouTube. I think they're expecting it to start at 1, but we're like 4 minutes ahead of time. So anyway, we'll just get started.
Yep.
I'll announce it now. Let me make sure I've got everything up and going. Everything's set up. Okay. Power to the truth. This is Sunday, August 19th, 2018, and I'm Margo. I will be your host for today, and I have with me Robin Westenra from New Zealand, and we're going to bring you an Arctic sea ice report and update. And so we're going to be discussing our latest discoveries and research on the Arctic sea ice, and Robin will be leaving after about 30 minutes, and I will continue with some more breaking news that I want to bring to everyone. So welcome, Robin. Thank you so much for making
Hi.
the time to join me today.
Yeah, I'm still just waking up.
Yeah, I know. It's you're 19 hours ahead of me,
Yeah.
so it's 1 o'clock my time, 8 o'clock in the morning your time, 1 p.m. my time. So thank you for making the effort in coming today. I'm going to switch the screen share. Hang on a second, and we'll get the right screen up. We're going to start. You and I have been looking at this NASA worldview and really looking in deep detail on this. And we have both come up with our own ways of looking at it and interpreting and reporting and everything. So have you had a chance to look at today's data on
No,
NASA
no,
worldview?
I haven't. I had a quick look at Sam Karana's article, but I'm
Mm-hmm.
just looking at what I'm seeing right in front of me at the moment, and that's amazing. That's about as clear as you can see it. I mean,
There's no cloud cover in this area.
yeah,
I've got the overlay, and for people who have not seen my show from yesterday, you need to go back and see that. And I explain all about this overlay on NASA Worldview, where we can see the sea surface, the ice surface temperature. And what that shows us is where there are no clouds, because they can't read the ice surface temperature through cloud cover. And so we're using this as a tool to see where we can zoom in and look at the ice. And so here's the overlay. And so it's quite clear of cloud. There's a little bit of cloud here. And of course, this is Greenland down here. So we've been watching this area very closely because this is an area that is not melted in the past because it's part of the older ice. And we've been following this. Some other people, I think Robert Fanny did a whole report on the ice lifting here. So here it is from today. Now, not all of their data is in yet. We can see it's still coming in over here on the left side, but so we can look at what we have from today. There's quite a bit of cloud cover because there are new storms forming, but it is quite clear down here above Greenland. So I thought we'd just zoom in and take a look at that first of all, and then we can look at whatever you want to. How's that?
Yeah, yeah, but I mean, this seems to be the most amazing thing because this is where all the thickest ice in the whole of the Arctic
And I've got
has been, and it's lifting.
I've got the Navy website geared up here, and this is their sea ice thickness from today, and we can see the area that we're looking at is right here above Greenland, and you can see that the thickest has historically been around this whole northern edge from Greenland and Canada, and it's really like it's diminishing, and it's coming down to almost it's nothing here over this first part of Greenland, and then it's also breaking up here, and we can see that in the world view today. Over to the left, let me zoom back out. There's an ice. I'll see how much we can see. There is a little bit of cloud cover right here, but we can look over here to the left of that in this flat area. And what you can see is it's breaking up. You can see the beginnings of it, and you can see the cracks. See these dark lines? I'm with my pointer. See where my pointer is going? Those are cracks in the ice. These dark lines coming across, that's all cracks in the ice. So that's getting ready to go as well. But we have to take advantage of these times when there's no cloud cover and really zoom in and get a good look at just at the integrity and how far apart these ice chunks are and how small they are, and how much further the ice is receding from the coast. I mean, that it just flips me out to see this.
Mm.
What are your thoughts?
Yeah, well, exactly. And I mean, I hadn't seen so clearly how far out from the coast,
Mm-hmm.
that's happening, and what I'm seeing right now, it's going right up. So
It's a
I,
huge area, and it's
yeah,
actually going, if you can imagine, you can kind of see a demarcation on further up here. Let me get this. Yeah, okay, so this is cloud free. This is all cloud free where that green is. And so it's where this line, you can see the outline where it looks flat. That's where it's cloud free, where we're actually seeing the ice.
yeah. Now that was an important point that you made, which I hadn't noticed. And then when I looked, it's so true compared with
Mm-hmm.
previous years that the ice just looks flat, and that seems to indicate
Mm-hmm.
that perhaps it's lost its integrity because there should be lots of cragginess and
Mm-hmm. You would think. But you can see the cracks.
yeah,
Those are cracks forming. And then we can also see the temperature of the ice wherever I move my cursor. And right now it's showing 271.7 Kelvin, which is above freezing for salt water. That's
yeah,
above freezing because it's 271.5 for freezing for salt water. So we have a mix here of salt and fresh water. And so, and then the melting point for fresh water is 273.1 or something like that. So it's all very close in that frame.
Yeah.
And we can see, let's look down here. See, that is where I have my cursor there above Greenland. That temperature is 273.9. So that is definitely above freezing.
And this
for
would be mostly fresh water, wouldn't it? I mean, if it's old ice.
Yeah, I think so.
Yeah.
But it's melting. It's coming up. It's melting from the underneath
Yeah.
because the sea surface temperature coming in from the Atlantic is so warm that as it's coming in, it's mixing underneath with the currents and stuff, and that's kind of what's going on. But that's just incredible to me.
Yeah. So that whole northern edge of Greenland and Canada was all old, more than 2 meter thick ice, and now the only parts are all the top of Canada, the very top of Canada, and all those little inlets.
Well, I just flipped back a year,
Yeah.
and here's what it was a year ago today.
Yeah. Oh wow.
And some of that is cloud cover, but this part is not cloud cover.
No.
That's solid ice.
Yeah.
See, that's solid ice there, and that's just last year. See?
Yeah.
That is solid ice all the way up to the coast.
Yeah.
All the way up. And it's cracked. You can see the cracks through, but you don't see it breaking away from the coastline, or you don't see it melting going down these little tributaries coming out. So this is the difference from 1 year. It's incredible to me. Okay, let's look at this area.
And
That's last year.
Yeah, I'm no expert, but it would seem to me that it would be impossible for it to be lifting away like this if this was due to, high air temperatures. This has to have happened from below.
That's what Robert Fanning said in that video, that he says it's from the warm water coming from below. And there's some climate scientists who have reported on this too. I'm not recalling offhand who they are, but there are some who are saying it's melting from below. So let's go back to 2016 and see what it looked like. Okay, so let's see what kind of cloud cover we had. It was quite cloudy. So what I'm going to do is find a day that was near that day where there's less cloud cover in 2016. Okay, let's look over here at this big patch and see how much melting there was. That was August 17th. Look at that. There was not much at all. It went all the way up to the coast, and it was just breaking off right on this little tippy edge. But all of that's ice-free this year. You can see it was breaking, but it didn't. And we can even go forward like a month. And this is at the end of their melt season, and see kind of where it was at. And these are the kinds of things that can be looked at. I'm thinking after our melt season is over, we can look more in detail and start and be comparing the years, later on, and then do updates and reports from that. Because so see, it was solid. That was at the end of the melt season. It was solid right along here, and it was not right on that tippy edge, but it was solid there. Okay, here's some ice area. Let's look at this. That looks like a good area to look at. It was cracked. It was cracked, but it went all the way up to the coastline. See? It hadn't broken off in huge chunks like it has already. So we're ahead. We're way ahead of the game, I'm thinking, in our melting. And
Yeah,
it does,
oh, yeah, sorry.
it does melt. I mean, there are areas of the Arctic that does melt. And it's a matter of how much it melts and how much it breaks apart, and then how much does it come back the next year. So, and you can see even at September 19th, we're starting to get a blackout where we don't have sunlight up there, because that's I think it's around the 9th is when the sun starts setting, going down, and so unless the sun is up, we can't get satellite images. So I can show you. See, there it was on the 9th, and I think it's around the 9th or 10th or 12th or 13th. There on the 14th, you can start seeing the hole, and that's where it's changing season and it's going into their fall, and then they go into no sun at all for months, and that's when the sea ice comes back. So do you want to look at anything else while I'm hopped over to 2016?
Make an observation that 2012 was the benchmark for the greatest reduction of the the ice extent. And
right.
if you go back and have a look at 2012,
yeah, I just pulled it up.
It's absolutely solid, untouched.
Okay, now here's this is from September 14th of 2012. So this was towards the end of the melt season, and let me find a day where there's less cloud cover. Well, let's look up here. I'll just zoom in and then take that layer off. I'm not seeing a lot of cracks. I mean, the ice looks good. It looks, I mean, it's melted up here.
Yeah,
but we expected that.
But if you look along the edge, there's nothing.
That's way far in on the extent.
Yeah.
And so, yeah, it was the extent is what they were worried about. But the thickness, and, the thickness was good. Now I can tell these are clouds right here. Let's find a day. Well, let's look over here. Let's zoom in and see the ice on the coast here. Now that's broken up.
Yeah.
It's broken up, but it's large pieces, and it's frozen right up on the coastlines, it looks like. So it did do some melt and refreeze, but it didn't go away in the big chunks. I want to find a day in 2012 where we can look at this edge of Greenland without clouds. Oh, let's look at this area.
Yeah.
And quite a bit different than this year.
Yeah,
and
yeah.
that's a month ahead of where we are.
That's how ice tracks,
Yeah. I still want to find a day where we can look at this area. It's hard because the cloud cover, well, you just kind of have to inch along and use your imagination and put the dots together. Okay, so it was cracked, but it had integrity, it looks like. It wasn't all broken up into like ice cubes. And let me go back a few days because I'm kind of, well, let's look here. Okay, here we go. Well, there was definitely more ice because this year already there's like no ice around here.
And that process started in July, didn't it? When we first
Oh,
got
the
the
melting?
report?
I think
Well,
so.
Robert
Around,
Fanny's report.
I think it started, we started losing this ice up here on the northern coast of Greenland. I think it was in July.
Yes. So that's not September.
No, no. We can look at July from 2012. We can look at August. There's July.
Yeah.
So that's that layer isn't working there for whatever reason. It was broken up, but it was still there. I mean, we don't
Yeah.
have ice there.
Yeah. Yeah.
Let's look at August. Okay, that layer is working here. I'm just trying to find a day without a bunch of cloud cover to look at. Well, some days it looks like that layer isn't working. Well, we're just going to have to eyeball it and see. See, there's a lot of clouds. It's hard to tell there. Oh, I've changed. Somehow it got to 2016. We're still looking at 2012, right?
Yeah.
Oh, here we go. This is a good day. Look, let's look at this. Okay, this is from August 25th, 2012. And this is the sea ice.
Yeah. Yeah.
That's much different. I did have some melting along the coastlines, it looks like. So we could have some things that are real similar to 2012, but I see two huge differences or three huge differences. The first one is it's melted away from the Greenland coast, way far out. Also, our extent has already melted in so much further on the east side than it did even in 2012. And the third thing is that the ice was much, much thicker in 2012. And so those are the differences that I really see. Thoughts on that? Want me to zoom in up here? See this, we could almost say, well, that looks like our sea ice right now. And so there are a lot of similarities to how it's melting from 2012, it looks like. And it looks there, the Beaufort Gyre, that was open at this time in 2012, like it is now. So I wonder what this blue stuff is.
Yeah, that's what
It's,
I was wondering.
I haven't seen that before. I don't know. I don't have any other layers on that would show blue. Maybe it's the corrected reflectance true color. How weird. Or maybe it's just because it's from 2012 and it was something from how they collected the data then and they're not collecting it like that now or something like that. But yeah, the extent really came in. But it was still, even out here, we don't see it cracking. Well, some cracking. Well, that's at 86 degrees north latitude.
Yeah.
There's a big area there, flat area. But it's still ice.
Mm-hmm.
So you really, it's like reading this ice I've found is an art form.
Yeah.
You really have to develop an eye to figure out like where the cracks are and the difference between clouds and ice and where the melting ponds are. And, it's not an easy task.
Can you
And
tell? Oh, yeah.
go ahead.
Can you tell the difference? I was just thinking of what you were identifying yesterday. Can you tell the difference between what are melt ponds and what and being able to sort of see the sea underneath, seeing right through?
I don't even know exactly what a melt pond is. I'd have to do some research on that, and I'm happy to do that.
But
What's your
I think that's
understanding
where
of
the
a
top
melt
of the
pond?
ice has melted away, and then you get water that's sort of sitting on top of the ice. But I'm sort of figuring that a lot of the ice is too thin for that to happen. That instead of getting a lot of melt ponds,
That's
it might.
my thought too. Like, so something has to be at the bottom to hold the water, but it looks to me like it's melting through.
Yeah.
And, on some of these, like this might be a
Yeah.
melt pond here where it looks darker. And so the color of the ocean is coming through, the darker, but we're not actually seeing the ice broken up there. So maybe something like that. I'll have to look into that, but that's a
And there
good
were
question.
there were huge melt ponds in 2012. The photograph on my Facebook page is taken from that. They actually had cameras back then, that
Mm-hmm.
that could capture it, and they were huge, but they were just that. They were ponds. They weren't. This wasn't open ocean.
Well, if you could figure out where that picture was taken from, if you had the coordinates, I could
Yeah,
look it
I
up.
have to go back
You know.
to Robert Scribbler. That's where I got it from.
Okay. Well,
Mm,
let's do some research offline and see if we can find some of
mm.
these and see what they look like, and then we can compare them to this year. I think that would be a good thing.
The terrible thing is that those cameras don't seem to be working anymore. I mean, they were a wonderful
Yeah. Well,
resource.
they might be
It
working,
looked
but
like on the ground.
they might be working, but we're not seeing them, huh?
I think they're not working.
Yeah. Anyway, so that's 2012. Um, so we've been on almost 30 minutes. Is there anything else you want to go over?
Uh, no, no. But I mean, I just thought it was a brilliant insight that you had yesterday. the last couple of days on how to read this
Oh,
using
thank you.
that
Yeah,
overlay.
it was quite a revelation to me
Yeah,
because, you know, just looking at this, you wouldn't know that that's all ice.
yeah.
That's a huge area. I mean, it's almost the whole Arctic. Now, this is 2012, August 23rd, 2012. So you know, I probably need to bookmark this page because this would be a great day to come back and study. In fact, I will. I'm going to bookmark this page and I'm going to call it 8/23/2012 because we rarely have a day where it's so cloud free where we can study so much of the Arctic, of the sea ice here.
Good.
And isn't that something?
Yeah, and that's a huge area that's
It's
above
humongous.
everything, you know.
It's humongous, I know. And it even it comes down to the coastline of Greenland.
Yeah.
So we can study part of that. And this will be something we can do in the wintertime when our melt season is over and we're twiddling our thumbs and,
Yeah.
you know, if we're still here, like I said, if we're still here, you know.
We might be watching Antarctica.
Yeah, or we might be on the spaceship. You never know.
Yeah, well, that's right.
We might be looking down from the
We might be
spaceship and
getting
saying,
50 gigaton, you know, thing of
I
methane.
know, we might be blowing up with methane. Speaking of methane, do you want to hop over and check that out real quick? I've got cams
Yeah, well,
up.
that's sort of brief.
Okay. I've got cams up. They have the latest data goes to Friday. Do you want me to run the movie? I can run the movie from
Yeah,
last
I've
Wednesday.
never worked out how to do that. That's never worked for me.
Oh, well, you have to be in the
So,
in
you
the
do it,
charts view.
and I'll watch what you're doing.
Yeah, well, you have to be in the charts view where you can, and that's different than the plots view. Now, this is the
Oh,
plots view, okay? It's
oh,
two different parts of the website, and that's what I was trying to explain. If you want that flat world view with the big one where you fill up the screen, you
yeah,
do it from here, the
yeah,
plots
yeah,
view, like that. And it defaults to total column,
yeah,
all right? So if you want surface level, you go over here
yeah. I've
and
got
then you
all that.
choose.
Yeah,
Okay, so that's the plots view, but we're wanting to focus in on the Arctic. Now there are two northern views that you can choose. The one I have on right now, and I have this bookmarked, and this is the one I share in the links under all my videos, is the North Pole down here. It says
yeah,
North Pole, and so it's showing the Arctic and then the whole northern hemisphere as well. Now, if you click on, and I like both, and if you click on Arctic, it zooms in closer on the Arctic view, see? And then
mhm,
you get less of the northern
mhm.
hemisphere. So you can really get a really good picture of what's going on with the methane. And I've got it at surface level. And so this is the methane coming up from the surface, whether it's from the ocean or from the ground or whatever, and 2 meters above. And my base time is, I went back to the 15th so that we can look at what the methane has been doing for the last few days. Then we have data through the 17th, and then so from the 15th through the 17th, this will be actual data, and then the last 2 days will be the forecast period. So it'll show like where it's leading up to according to the data that's been entered. And like every day when I look at this, it's like worse than the day before. It blows my mind. It's just I just can't believe that we're able to watch all of this and we're able to view it and we're able to report on it basically in real time. I feel like we're reporters and, it's like, hey, it's Margo and Robin, and we're live in the North Pole looking at the sea ice, and then we're looking at methane and this and that. And like I was telling you in our chatting, this is historical, and whether or not we have a blue ocean event is a moot point, because we are living in historical times with this sea ice melting, and it's part of the sixth mass extinction, and we're already seeing the effects of the changing Arctic sea ice with all of the crazy weather and the droughts and the floods and the fires and the heat. And I'll go over Sam Carana's post after you and I get done, but the rundown is he's thinking that August might be the hottest month ever recorded. And did you read his article where at the bottom he said we could be experiencing 3C hotter right now?
Mm-hmm.
Right now. And that's his bottom line. And he goes into a bunch of reasons why, and I'll be sharing that article. But let's just talk about this. Have you ever seen the methane like this? You see the screen, Robin?
Yeah, yeah.
Have you ever seen the methane hopping up like that?
No,
From
and
it's
the first time, I'm not seeing it right at the moment, but seeing methane in the East Siberian.
mm-hmm. And you've shown as well, when you go up through the layers of the atmosphere, it's collecting, it's not dissipating.
No,
It's supposed to break up
and
and
it's right
turn in.
there in the Arctic,
It's supposed to break up and turn into water and carbon dioxide, but it's collecting. But that is so troubling. And look at all of that red just popping up from this is that East Siberia ice shelf. And then coming up off of Norway and Sweden and Finland, and here's Novaya Zemlya and all the nuclear radiation from there and from the ocean, and it's like, oh my God. I mean, I had a headache when I woke up today. It's gone now, but I'm like, oh my God, I've got to show this stuff today.
Look at that. Oh. Yeah, that.
Isn't that incredible?
Yeah. Now all that green,
What?
that's still emissions, isn't it?
What?
All the green, where it shows
Oh,
green.
yeah, we can go over the readings. The green is still high.
Yeah,
I
that's what
mean,
I mean, it's
it's not like
still in another area.
this is
Still
not. It's
emitting
not
quite
like the
high
green is.
levels.
It's not like the green is nothing.
Yeah,
No,
exactly.
I mean, like this color, this yellow chartreuse is 1920 parts per billion. Then the lesser green is 1900, and then this kind of like green, I call it green, is 1980. So like this green over Greenland is 1980 parts per billion.
Mm. But if I could delve into my memory, I'm not very good with figures, but the figure of 1800 parts per billion, in years gone by, were those kind of fairly high levels. I mean, there were bursts that were higher than that, but,
Right.
but the sort of average high, as it were, it seems to me was about 1800, which is the green now.
Right. And let me pause this, and we can look at it worldwide. You can see it's that level worldwide. Pretty much. Well, the whole northern hemisphere, from the equator up, it's at least 18 1820, 1800. From the equator up, it's 1800. And then from the equator, oh, I didn't mean to, hang on. I didn't mean to do that. I was just going to move the picture. And then down here in this kind of aqua color, that's 1800. And then as you go more aqua, it's 1780. And so since we had that methane burst, there was a methane burst at the end of May when the whole northern hemisphere kind of went this orangey color over here. And I did a video about it. It was right after that last interview I did with Guy. I did a video about the methane burst. So, you know, we can go back and look at that sometime and see how like everything went to this higher, like this orangey and this higher color over the whole northern hemisphere, and it's taken since then for that orangey color to kind of dissipate and go back to green. And if you look at some like my first video that I did with the methane and stuff, which was April 28th, the colors are so different. Like down here in the southern hemisphere, it was like this blue color, 1740. And now it's 1800, 1780 and 1800. So that's how much the overall global methane level has increased just from April, okay, May, June, July, 4 months. It's incredible.
Yeah. And I'm looking sort of selfishly at my own area, New Zealand, and that's at what level? I mean, that's
you're green.
That's quite high because I know that they've discovered clathrates off the coast of New Zealand.
Well, and you can see. I'll zoom in on it here. Move it over. Well, I wanted to zoom in and show New Zealand.
Yeah.
There you go. There's New Zealand. It's having to load again. But you do have methane on the coast, and it gets quite high. It's up in the red zone.
For a non-industrial country, it's got
I know, and that's where everybody wants to move to.
But we do have plenty of cows, so they use methane.
And we can see methane. Now, New Zealand is in two islands. There's uh-oh. I have to hold it while it does that. There are two, there's a northern island and the southern island. And so you can see on the coast, you do get the red, but overall you're in the green.
Yeah.
So that's quite high for one of the supposedly not well developed small countries in the world. Look at that. No, you've got methane, dude.
I wonder when that was.
Huh?
I wonder when that was. Yeah.
That was the 19th.
Find that.
Well, that was earlier today.
Yeah, wow.
Well, no, it looks like it's in the forecast period because they only have methane through the 17th. So we're in the forecast period now. So when the movie starts over, see, it's slower on this view. Look at that. Look at southern New Zealand. See? No, you have quite a bit of methane. Wherever you have industrial civilization, you've got methane. And if you've got any kind of humid conditions or things like that, you've got methane. Also, drilling for oil or natural gas extractions, you're going to have methane come up. Okay, here it started over. So yeah, it was from the last few days. And the readings go down at night, remember? And then once it warms up in the daytime, then the methane comes up. And you're in wintertime, so you're gonna have more methane once you hit your summertime.
Mm.
That's quite high for a little tiny place.
Yeah.
So there you go. Well, I've had you on the line for 40 minutes.
Yeah.
So
Okay.
I
Well,
appreciate you being here.
I'll mute now. If I
Okay.
how to do it. Yeah.
Okay. Well, thanks for joining us for our update. And
Oh no,
before,
it's been a pleasure.
yeah, and I love sharing information and ideas with you. And it's like we just bounce off of each other, and then you write it up, I do videos, and it's a good mix, because some people don't want to sit and watch a 2-hour video, but you'll get the highlights and write it up, and they say, well, just give me the facts, and so you've got your blog that's really great, and so I think it's a good mix. We're a good team. So
Yep, yep.
power to the truth. So
True,
thank
true.
you, Robin. So
Okay.
while that methane is running, I'm gonna pop over to my YouTube chat room and see what's going on. Um, we go. Oh, I'm spooling. Okay. Okay, I hope everyone has been behaving themselves. I put everyone on the honor code over here. I'm gonna give a shout out to the people in the chat room. Um, I've got to scroll back up, and then we're going to go over a couple more things. First of all, we are going to have a campfire chat this Thursday, August 23rd at 5 p.m. Pacific time. I will do an announcement and put that up. Shout out to Les Winter. Thank you for coming. Shout out to Lex Green. Thank you for coming. Shout out to Angel's View. Thank you for being here. Shout out to Omega Man. Thank you for being here. And Eric Meredith, thanks for joining. And Redwater and Lily, thanks for being here. Wow, I've got 39 watching. And I've got 7 thumbs up already. Well, this is awesome. Hey, Louise, thanks for being here. I feel like I've just got a whole bunch of friends here. Hey, Wills, thank you for being here. Um, Pima Thamo, thank you for joining us today. Merrick Jaworski. Yes, I know that Guy McPherson said we would have one more year, and I addressed that yesterday. And any extra comments about that, you know, I'm not commenting on that anymore. And comments about Guy and what he said, yeah, they I addressed that yesterday in my video, and that's all I'm going to say about that. Because we're here witnessing what's going on, and we're here reporting the actual data and showing you in real time what's going on, not just giving opinions or predictions. Hey, tree hugger. Thanks for joining me. Hello, Gray Silverback. Thanks for joining me. And I think I'm through all the people. So now I'm going to change. I'm going to stop that. I've got a couple of articles a couple of things I want to go over with everyone. In case anybody is not aware, but there was an 8.2 earthquake in the South Pacific last night. Here it is. This is on the USGS website, and it was it's in this blue dot, and it's near Fiji. And there have been a lot of aftershocks. And here's New Zealand down here. Here's Australia. There was also there have been some large earthquakes over in Indonesia in the last couple of days. But I really wanted to talk about this 8.2 that struck last night in Fiji. And it was 563.4 kilometers deep. And Dutch Sense did a report on this right after it happened, and he's been reporting on it since then. And he was stunned with this because he said it's the largest and deepest earthquake that he has ever seen. And he was saying that because of this, because it was so deep, that it's going to be causing earthquakes around the world. And I saw another report somewhere that like the seismograph charts where, it's registering earthquakes, like they were all just like going crazy. It was off the charts when this happened. So it was felt worldwide. So this is important because as this ice melts and the permafrost melts and the weight is lifted off of some of these areas, then the tectonic plates start moving and shifting. And as this happens, you're going to have more earthquakes, you're going to see more volcanic activity, and the earth is shaking and quaking. And last week I reported on the earthquakes up in the Arctic region that had been happening. And now here are all these earthquakes that have been going on since that 8.2 last night. And we can see it's constantly being upgraded here on the left on USGS. And they're happening at Fiji, Vanuatu, Fiji. I mean, just in the last few minutes, we've had a 4.6 in Fiji, 4.8 in Vanuatu, 4.6 in Fiji, 5.4 Fiji, 4.8 Fiji, 4.6 Fiji, and it just goes on and on and on. Here's a 5.4 New Zealand. As I'm scrolling back, here's a 5.0 Papua New Guinea, 5.2 Fiji. So here's a 6.8 Fiji. So these are not nothing aftershocks. Here's a 6.3 Fiji, 8, and there's the 8.2. So I will leave the link below in the archive so that you can be looking at this as well. And also, there's one more thing I want to go over. This is Sam Carana's latest article. Now, I realized that I've been talking about Sam Carana and reading stuff from his blog and stuff like that, and didn't really explain who Sam Carana is and why Sam Carana is a pseudonym. We don't know, no one knows exactly who Sam Carana is, but Sam Carana, we believe, is climate expert. Maybe Sam Carana works for a government agency. I don't know, but he or she or the group has been doing this blog and following the Arctic news for a very long time, and back to 2011. And this is the website is arctic-news.blogspot.com, and they also have a Facebook group. If you want to see all the latest in the Arctic news, you can go to the Facebook group, Arctic News. And that's Sam Carana's blog, Facebook group. But the reason Sam Carana remains anonymous is because there's so much cover-up going on the truth about climate change and about what bad situation we're in. I mean, you saw what happened with Guy McPherson, and people are losing their jobs and losing their lives and being threatened and stuff, because if they come out with the truth, and this is not any different than whistleblowers in any other area. And so anytime there's a cover up, and it appears that there is a cover up by certain government agencies and the media, and none of this is being reported on mainstream media. Now some of the things are coming out and actually being reported with all the heat, because of all the heat and the wildfires and the flooding. I mean, eventually you can't ignore what's going on. And so for his own protection, Sam Carana has decided to remain anonymous. And I totally respect Sam Carana. And so what you have to look at is the data. And these are the contributors. All of these people, a lot of them are scientists, okay? And you can go and look for yourself. Peter Wadhams, who does research in the Arctic, Malcolm Light, Paul Beckwith, Harold Hensel. I know Guy McPherson. Here's Guy McPherson. He's a contributor. I mean, and here's Sam Carana at the bottom. These are all contributors, and they have their own blog posts, and you can go down here and find their own blog posts. So don't throw the baby out with the bathwater. And just because he's hiding his true identity doesn't mean that this is not good information. This is scientific data, and you can do the research yourself. If you don't believe it, you can do the research yourself, but the reports he puts together are phenomenal. So that's all I'm going to say about that, and I'm not going to go into that in great detail again. And if you don't want to hear about Sam Carana, you can go do your research somewhere else. But I do trust his information because I've been reading it and watching it and studying it, and I find that it's right on. I've been watching it for a long time now. So here's his latest blog post from today, the 19th. And he says, will August 2018 be the hottest month on record? So then he's got this chart, and here we are at July 2018 at 2.2 C above baseline. 2.2 C. So I'm just going to read this article, and then we can talk about it in the chat, but I'm probably going to just wind up the show after this because we've looked at a lot today. July and August are typically about 3.6 C or 6.5 degrees Fahrenheit warmer than December and January. August is typically 1.8 degrees Celsius or 3.24 degrees Fahrenheit warmer than the average annual temperature. Above image shows how much higher the temperature was for selected months compared to the annual global mean for the period 1980 to 2015. Will August 2018 be the hottest month on record? Numerous temperature records have fallen across the world recently. Heat stress hazard is high under conditions of high surface air temperature and high relative humidity. When looking at heat stress hazards, it's therefore important to look at surface air temperatures over land, i.e. the temperature of the air above the land surface. Fire hazard is high under conditions of hot and dry soil and strong wind. When looking at fire hazards, It's therefore important to look at land surface temperatures, reflecting how hot the surface of the Earth would feel to touch in a particular location. The map below shows land surface temperatures. So on August the 10th, this is land surface temperatures for August the 10th, compared from 2002 to 2012, and an average for August 5th to 15th in Celsius. So you can see that it's 15 degrees. This red is 15 degrees hotter. And it's red like over half of this map that he's showing. When calculating how much warmer it is now, a number of things must be taken into account. 1. Baseline. What baseline is used and how is the temperature at the baseline calculated? In the image at the top, the baseline is 1980 to 2015, which is a very recent period. When using a pre-industrial baseline, anomalies could be more than 0.6 degrees Celsius higher than when using the 1951 to 1980 baseline that NASA normally uses. 2. Surface temperatures or surface air temperatures. Above map shows land surface temperatures. As said above, this is different from surface air temperatures over land that show the temperature of the air above the land surface. Similarly, sea surface temperatures indicate the temperature of the water at the surface. Sea surface air temperatures, on the other hand, are slightly higher. They are measurements of the air temperature just above the surface of the water. NASA typically uses surface air temperatures over land, while using surface water temperatures over oceans. When instead of using air temperatures globally, the temperature anomaly could be more than 0.1 degrees C higher. 3. Missing data. How are missing data dealt with? To calculate the global means on maps, NASA uses 4 zonal regions: 90 to 24 degrees south, 24 to 0 degrees south, 0 to 24 degrees north, and 24 to 90 degrees north, and fills gaps in a region by the mean over the available data in that region. In data sets, however, missing data are typically ignored. This could make a difference of 0.2 degrees C. Ignoring data for the Arctic alone could make a difference of 0.1 degrees C. Depending on how the above 3 points are dealt with, the temperature in August 2018 may well be more than 3 degrees C above the mean annual global temperature of 1750. The question is whether August 2018 will be warmer than August 2016, which was 2.3 degrees C warmer than 1980 to 2015. By the way, remember the Paris Agreement when politicians pledged to take efforts to ensure that the temperature would not cross 1.5 degrees C above pre-industrial? The situation is dire and calls for comprehensive and effective action as described in the climate plan, which he has on his website. So did you get all that? Do you understand what he's saying here? Because of the different ways of measuring the temperature, there's a lot of data that's not being addressed or reported or being ignored. And because of that, we could already be 3 degrees Celsius above the annual global temperature of 1750. So, which means we hit above 2C a long time ago, for the summer at least. So I hope that hits home. So we're in trouble. We're in big, big trouble. It's time to get your spiritual houses in order. It's time for us to get serious about things. And time is short. Time is short, folks. I'm going to hop over to the chat room and see what's going on over there. See if there's anything to look at or address. So yeah. So I'd like to thank everyone for joining me today. I will do an announcement video for the campfire chats, but we will be having campfire chats on Thursday. And that's at 5 p.m. Pacific time on Thursday. And I'm going to hop back over to NASA Worldview. And let's look at 2018. And so it looks like we've got all of our data. Oh, no, that's 2012. We're still lacking data for today on NASA Worldview. So I'll just leave you with this NASA Worldview from today, from yesterday, August 18th, 2018. Time is short. My name is Margo. My website is margoshealingcorner.com. I'd like to thank Robin for joining me in the discussion today. And I'd like to thank all my viewers, and I would like to thank everyone over at YouTube and thank my viewers and subscribers. And I love you guys. I love all of you. Time is short. And until next time, go in peace. God bless everyone. Take care and power to the truth. Goodbye.